Hello, welcome to Level 314. Today we'll be taking a slight detour from our series on solving the genius square to spend some time thinking about COVID-19, or what's known as the coronavirus. Now, we're not doing this to cause panic, but rather the opposite. I want to make sure that we are prepared and just taking necessary precautions to protect ourselves from the spread of this virus. Now, there are some people that are going around spreading false information or making decisions or proclamations based on a hunch, but here at Level 314 we are dedicated to making rational decisions based on data. So that's exactly what we're going to do today. We're going to look at the data that the World Health Organization puts out each day in their situation report. And what they've done is they've created these tables which give the statistics regarding the spread of the virus. So we can find places online where there are Kaggles that have been created where people have scraped this data and put it into a CSV file. I've gone ahead and downloaded that file in a zip format and extracted it. And you can see here, if we open up one of the files, they're just CSV files full of data with date and time stamps and vital statistics about the spread of the virus. So what we can do then is, using Python and a few modules which we've imported. Pandas is one of the modules. This is something that we use to load data sets and manipulate it. Plot.ly is another one, and that's, as it probably sounds, it's for plotting the data. And we've imported these modules. You may need to go ahead and install the modules using conda install or pip. I'll put some details in the README for this and links to all these downloads in the description. So I've gone ahead and started the code here, but let me just go ahead and finish it. We've done our imports, we've done our df equals, and this is reading in the file into what's called a data frame. You're going to want to get to know Panda very well for manipulating files and data this way. Again, I'll put links in the description for Panda as well. Okay, we have our data sets loaded. Let's go ahead and create our plots. So we'll call this a figure or fig, and we're going to use our PX abbreviation for plot.ly express, and we are going to create what's known as a choropleth. A choropleth plot is a plot that is applying data to geographical map. So, and here's, if we just hover here for a moment, you can see all the different values. I'll go ahead and fill some of these in. This is important. The color says which values we're going to be using from our data frame to determine what color each of the map areas are going to be. Hover name says which name will pop up when we hover over a geographic area. This is the title of our graph. So we're saying we're going to not show our frames or our coastlines. Feel free to look at the different options here and go ahead and make some updates as you see fit. Make some changes and see how it changes your graph. And now we go ahead and plot. So that's it. We're done. This is the code to make our choropleth graph, and we run it, and it will open up the graph right here in your browser, and you can see it's an animated graph, and you can watch as the date goes on how the virus has spread throughout the world. As we get more data, as the World Health Organization releases their data day by day, we can download the new data set and just simply run the program again, and we can really watch this evolve over time with a simple program that you've created. Okay, but one thing we notice is that because the outbreak started in China, it dominates the chart here, it dominates the graph. So what I've done is I've visualized it another way using a different choropleth graph here in the version 2 using the plot.ly graph objects. I'm abbreviating that as Go here. And you can see I did a go dot figure and then here choropleth again. The thing that I did with this data set, you'll see here, let me zoom in a little bit for you. I've done the DF countries here, the data frame for countries, but I made another data frame with countries, no China, by simply saying take our original data frame, and when the country value is not equal to mainland China, which is how China is listed in our data set. So if we go ahead and run that, we'll have our second way to visualize it. And you see China is omitted from this data set. You can see much of the world now is a light green, which is the lowest level on this heat map, if you will, besides the 0. And these are areas where it either hasn't been detected yet or there's no testing that's occurring really. But then you can see places like Italy and here in Iran are a little bit of a deeper green. Iran and Italy both have about 3,000 cases as of today, and then really the darkest green now on this map is South Korea with 5,621 cases. So those are two ways to visualize it with a choropleth graph. There are many other ways with plot.ly to view data. One of the ways I like to use to view data is with bar graphs. So you'll see this one. I've created bar. I've looked at the data by grouping it here, the data frame group by, and just changed it into bar graph data. And then I've done 3 different bar graphs, one for confirmed, one for recovering cases, and one for cases where the patient has become deceased. So let's run that. And again, it will make the plots that we've asked it to make. Now, one of the things I really love about the bar graphs is that we can see here that once again the confirmed cases, because it started in China, it really dominates the graph. It's where it's the most prevalent. But we can come right over here and click on mainland China, and you see it turns gray and it hides that data. So now we can really see the growth of the virus in other areas by just hiding that. And we can hide other ones, or we can put our mouse here and see an exact value on a particular date. We also have data here for recovered, and you can see same way. You see the same trend. Recoveries have been growing over time. One positive note here is you can see that the death rate was really starting to grow rapidly, but now it's leveled off. That's a good sign. We hope that that continues to level off and even decreases soon. And here, what I've done is another interesting way to view the data with a tree map. I'm not sure if you're familiar with that. I've done a tree map and a line graph here, so let's go ahead and run this so we can look at those. So this is the tree map, and again, I've done it excluding China, and you can see that each square, the size of the square, represents what portion of the data. And so this is sort of almost like a pie chart, but like a modern version of the pie chart. It's an interesting way to visualize the data. And here we get a good look at how the confirmed cases really took off around here, February 12th, when our testing really increased in China, and the way that they determined who had it and didn't change. So we saw a big jump here, but now we're seeing that the confirmed cases are not increasing as rapidly as during this phase. We're not sure yet whether it's because the efforts we're taking for slowing down the virus are working, or if we just saw this big jump because of the detection method. A good thing to note here is that you can see the number of deaths. It's a very flat line compared to the recovered and the confirmed. This is something, again, that we want to see, and it's an encouraging sign, not to get complacent, but also not to panic. And finally, what we did is we went and did a projection using a module called FB Profit. It's a way to analyze data and project the course of the data. This isn't quite what we'd want to use to do a really detailed analysis of the spread of a virus. We'd want to know the R value. We want to know some other information that we just don't have a handle on yet. So at this point, really this type of simple sampling and then analysis of the trend is one of the best ways to get a handle on where the virus is heading in the very near term. So you can go through the code. I'll put a link to it. We'll just run it here so you can see the result. And you see this blue dotted line is our projection, and the circles here are the actual data points, and you can see that our projection really maps well with the data point once it has enough data to start making a good prediction. The green and the red are the outer bounds of the range that we would expect for the value, and this says it's predicting that we'll surpass about 100,000 cases sometime within the next day or two. And really what we hope is to see this line start to level off and decrease soon. So that's the data. Here's how you can download it for yourself and do some charts and do some analysis in Python and not panic, but make decisions, use adequate precaution based on what the actual data is showing us. So that's how we're going to try to encourage people to make decisions based on the data. And we're just going to keep fighting the good fight with scientific information. So keep pushing ahead and keep taming irrationality bit by bit.